Hello friends, I welcome you in lecture number 11 on vector calculus. In lecture number 10, we have introduced about line integrals, and we have seen that if we have a vector function f bar, then line integral of vector function f bar along curve C is denoted by f bar dot dr bar along curve C and is defined as, if we consider parametric representation of a curve C as r bar t equal to some vector either in plane or in space, then this is equal to we will find out f bar of r bar t, and here we write dr bar by dt times dt. And in this parametric representation, suppose t runs from a to b, then here limits of integration will be from t equal to a to t equal to b. This is the definition of line integral which we have discussed in lecture number 10. Today we will see one question on the evaluation of line integral using this definition. So this question was asked in GTU Summer 2019 exam. The question is, evaluate integral of this vector function f bar along curve C, where C is the curve given by the parametric representation r bar t equal to t square I plus tj, and t runs from 0 to 2. So here we have given vector function is f bar equal to x square minus y square I plus 2xy j, and we have to integrate this vector function along curve C whose parametric representation is t square I plus tj. So first we write down given curve C is having parametric representation r bar t equal to t square I plus t into j, and limits of t are from 0 to 2. And here we can see r bar t is having two components and f bar is also function of two variables. So we are considering line integral in a plane. So this is a plane curve whose parametric representation is t square I plus tj. So if we compare r bar t with xti plus ytj, this is the general parametric representation in plane, r bar t equal to xti plus ytj. So if we compare this with this standard form of parametric representation, then we can see value of x component is here x of t is equal to t square and y of t equal to t, and limits of t are from 0 to 2. So using this x and y, first we will decide derivatives of x and y with respect to t because we will require them. Therefore dx by dt is 2 times t and dy by dt is derivative of t, which is 1. And now we consider values of x and y in terms of t in f bar, because we will require f bar of r bar t. So that we can obtain by putting x and y in terms of t, which are given here. xt is given as t square and value of y is t. So now we substitute x equal to t square and y equal to t in f bar. So that will give us f bar of r bar t. Okay, we can write in this way f bar of r bar t, that is we convert x and y in terms of t. F bar has x component x square minus y square, so we put x equal to t square. So we have square of t square, x square minus y square, x is t square, minus y square, y is t. So this is x component, x square minus y square times I, and y component is 2xy. Here also we put x equal to 2t square and y equal to t. 2xy, x is t square, y equal to t times j, and these two are in the addition. So now we simplify this. This will be t raised to 4 minus t square times I plus 2 times t square into t, that is 2 times t raised to 3 into j. So we have converted given vector function f bar in terms of single variable t. This is f bar of r bar t, and we now write down d r bar by dt that we will require. We have r bar equal to xti plus ytj. R bar is xti plus ytj. Therefore dr bar by dt will be equal to derivative of x with respect to t times I plus derivative of y with respect to t times j, and dx by dt we have obtained. Dx by dt is 2t, dy by dt is 1, so we have 2t times I plus dy by dt is 1, that is j cap. So here we can see dr bar by dt is equal to 2ti plus j, or we can write 1 into j. And now we have converted f bar in terms of t, and dr bar by dt is also obtained, and the range of t is 2. So now by the definition of line integral, this will be equal to, that is line integral of vector function f bar along curve C. Now f bar dot dr bar along curve C equal to f bar of r bar t times or dot product with dr bar by dt. Integral is with respect to t, and limits of t are from t equal to 0 to 2. We are given this limits of t in the parametric representation, and now we will put f bar equal to this, t raised to 4 minus t square plus 2t cube, and dr bar by dt is also obtained. So now we substitute first f bar of r bar t. This is 0 to 2. F bar of r bar t is t raised to 4 minus t square times 2 times t raised to 3 j. So let me check this value of vector function f bar, t raised to 4 minus t square and 2 times t cube, t raised to 4 minus t square plus 2 times t cube, dot product with dr bar by dt, which is 2t plus j, 2ti plus j. So here we write dr bar by dt, which is 2ti plus j, and here we write dt. So dr bar by dt we have first obtained. We have also converted given vector function f bar in terms of t, and now we have substituted values of these two quantities which are vector quantities, and now we will take their dot product, and after that we will integrate with respect to t from t equal to 0 to t equal to 2. Dot product is t raised to 4 minus t square times 2t, or 2t times t raised to 4 minus t square plus 2t cube times 1, that is 2 times t cube. and then we integrate with respect to t. So here we can observe that our line integral is converted in terms of definite real integral or real integral with limits, and this is easy to integrate. Before integrating, first we rewrite all these things. 2t into t raised to 4, that is 2 times t raised to 5 minus 2t into t square plus 2t raised to 3, and here we can see this will cancel each other, and the integral of 2 times t raised to 5 with respect to t, and 2 is constant. Integral of t raised to 5 is t raised to 6 divided by 6. Limits of t are from 0 to 2, and this is going to be 2 raised to 6 divided by 6 here, and minus t equal to 0. So here we can cancel out 1, 2, and this is going to be 2 raised to 6, that is 2 raised to 3 whole square, and 2 raised to 3 is 8 square divided by 3, which is 64 divided by 3. The value of given line integral is 64 divided by 3. So you can see this is very easy. What we have done, we are asked to evaluate this line integral. So first we use the parametric representation and we decide this vector derivative of r bar with respect to t. We also convert our vector function f bar in terms of t, and then we take dot product of these two vectors, and that will give us a real definite integral with respect to t. So ultimately we are converting line integral or integral along curve into the definite real integral of single variable, say t here, and we can easily evaluate this type of line integrals. Here answer of given line integral is 64 divided by 3. So again I can repeat here. Here we are given vector function f bar, and curve C is already given in parametric form. So we have x equal to t square, y equal to t. If we observe here, x component is t square, y component is t, and using x equal to t square, y equal to t, we decide the vector function f bar in terms of t, and then we take dot product of f bar with dr bar by dt, and dr bar by dt we obtain using this formula for position vector, and then we take dot product of dr bar by dt with vector function at r bar t, and we are able to decide the value of line integral. So this example is very easy. All you have to remember is, first you decide, or first you see that which vector function is given and which curve C is given along which we require the line integral, and then you try to write down your curve in parametric representation. If it is not given, then you have to decide the parametric representation for a given curve. Once we convert our curve, or once we write down parametric representation of a given curve, then here we convert everything in terms of t. So then we decide what is our vector function at r bar t, so that we obtain, and here this dr bar by dr bar can be written as derivative of r with respect to t times t. So this also we decide using the definition of dr bar by dt, okay, that is dx by dti plus dy by dt j, and we can convert our line integral into definite real integral. Here we can write that this is f bar at r bar t dot product with dr bar by dt, integral is with respect to t. So this is all about this session. I hope you like this. Thank you very much.